ඊට පස්සේ යන්න the biasing circuit. The biasing circuit. So we have to bias using the 2 voltage supply. මේ ගණන් හදන්න දෙන්න මේ හරි ලේසි හරි අර කලින් තියරේ 2 voltage supply right ලියන්න we can bias NPN transistor using we can bias NPN transistor using 2 external voltage supply. 2 external voltage supply. 2 external voltage supply. Right? So this is the diagram. So we need to bias to B and E to forward bias. We are using VBB. So in this case, I will use the RC. VCC. This is base, emitter, collector. So we are obtaining VCE, VBE. අපි මේ ඔක්කොම ගැන කතා කරන්නේ. ඊට පස්සේ මම මෙතෙන්ට දානවා තව resistance එකක් RB. මෙතනින් එනවා කරන්ට් එකක් IC. ඕනම තමයි බයස් කරන්න. සරි. හරි. Okay. Roll this one. We have to talk about separating. Write down පළවෙනි එක තමයි අපි ගන්නවා VBB equals 0. So when VBB equals 0, what should be happen? VBB 0 means there is no potential in this one. So this not bias in this junction. BE junction not bias. Therefore it is B to E. That means B and E not biased, therefore PN junction is not working. There is no IB current. IB current. IB equals IB equals. Therefore, if there is a current passing IC, that cannot also pass this one. Therefore, IC equals C. Right? That means the this one is in this region is what? VBB equals 0. When VBB equals 0, IB equals 0, IC equals 0. This is in which region? The active region, saturated region, or cutoff region? Cutoff region. Right? This is in cutoff region. මේක වැඩ කරන්නේ දැන් වැඩ කරන්නේ නැති මේ transistor එකේ වැඩක් නැහැ. ඒක තියෙන්නේ cutoff region. හරි. Okay, write down when VBB equals 0, when VBB equals 0, the potential barrier in BE junction potential barrier in BE junction not changed. Is not changed. Therefore, the transistor in cutoff region. Therefore, the transistor in cutoff region. IB equals to 0 and IC equals to 0. IB equals to 0 and IC equals to 0. There is no decreasement of potential across RC. Decreasement of potential across RC. Therefore, what is VCE? In this case, what is VCE? VCE equals to the VCC. VCE equals to the VCC. VCC. This is the maximum value for the VCE. This is the maximum value of the VCE. When second one is VBB higher than to the VBE. This is higher than. So normally we are using the 2 volt normal cell, right? එතකොට මේක ඇවිල්ලා 0.7 නේ. අක්කලා මේක 0.7 නේ මෙතන තියෙන බැරිය එක. ඒක අක්කලා නැති කරන්න පුළුවන්. right? එතකොට VBE නැති කරගෙන යනකොට මෙතන fault bias එක. එතකොට ඉතින් අපි වැඩි කරද්දී ඕන එකක් හරි විදිහට වෙනවා. කියන්නේ මේ වෙලාවේදී මොන රීජන් එකටද දෙන්නේ? මේක දිගටම වැඩ කරනවා. මෙතන fault bias වෙලා. So this is in active region. Active region, right? So write down the next one. When VBB greater than to the VBE, the transistor in active region, transistor in active region. Okay. So how can we find out what is the voltage and what is the potential using this diagram? We know the VBB value. So we have to apply Kirchhoff law to across the first loop. Considering first loop, sigma E equals sigma ER. So first loop, VBB equals IB RB BBE. So then we can find out the IB, right? BBE equals to the 0.7 volt in silicon transistor. IB can be found. Then using IC equals to beta into IB, we can find what is IC, right? IC can be found. Then we need to consider another loop. Why? We need to get the value of VCE. Find out the VCE. We have to apply the Kirchhoff law to this junction. Right? Therefore, considering second loop, apply KVL. Second loop එකට දැම්මොත් them make it sigma E equals sigma R. Sigma E mean what? VCC equals sigma R ICRC plus VCE. So then we can find the VCE, right? So VCE can be okay. This is the method. Okay, write down this one. Right. ඒක තමයි දැනගන්න ඕනේ. මේ problems වල එන්නේ ඕක තමයි. Then this is okay. So the what are the equation? BBB මේව මතක තියාගන්නත් එපා. මේව නිකන් රෙජිස්ටර් කරගන්න. IBRB BBE BCC equals ICRC BCE IC equals beta IB. Okay. Then write down when we increase further, when we increase VBB further, IB getting increased, IB getting increased, IB getting increased, then IC also getting increased, then IC also getting increased, because of that මොනවද වෙන්නේ මෙයා වැඩි වෙනවා මේකත් වැඩි වෙනවා මේක චේන්ජ් වෙන්නේ නැහැ නේ එතකොට IC කියන එක නා VCC කියලා කියන කොමන් වැලියු එක VCC කියලා කියන කොමන් වැලියු එක ICRC VCE කියලා කියන්නේ මොකක්ද VCC ICRC this is the constant value it's not changing why the supply of this one is not changing IC increasing VCC remains same therefore VCE getting decreased when VCE getting decreased further it can only goes to the value 0 when VCE is 0 VCE කියන එක න 0 වෙනකොට IC equals to the VCE equals to 0 IC equals to the ICRC so that is the saturation region right IC maximum is VCC over RC this is saturation region when we increase the further right when we increase the VB further the IC also getting increased so this is getting decreased when VCE equals to the VCE equals to the 0 normally එහෙම වෙන්නේ නැහැ 0.1 වගේ තියෙන 0.1 වගේ තියෙනවා 0 වෙනකොට හරිද IC VCE 0 IC is maximum so what is the IC maximum VCC equals ICRC plus VCE when VCE 0 VCC equals ICRC IC max VCC right so this is the way right okay write down when getting increased because of that VCE getting decreased VCE getting decreased right මේක කොහොමද දාගන්නු මෙතන තේරෙන්නේ නැත්තම් පස්ස බලන්න When VCE equals to 0, when VCE equals to 0, transistor in saturation region, transistor in saturation region, the IC having a maximum value. IC having a maximum value. Okay, write down IC max equals to this one. Right? Right? එතකොට තවත් වැඩි කරොත් තව මෙන්න මෙයා වැඩි කරොත් එහෙම තව BBB වැඩි කරොත් එහෙම මොනවා කරත් ආය වැඩි ආය VCE කියන එක නා මයිනස් වෙන වැලියු එකක් එන්න බෑ. ICC වැඩි වෙලා මේ දෙන්න මේ වෙලා මෙයාට වඩා මෙයා වැඩි වුණා කියලා මේක මයිනස් වැලියු එකක් වෙන්නේ නැහැ. So VCE cannot get the minus value. Why? VCE කියලා කියන්නේ මෙතන තියෙන voltage එකනේ. ඒ VCE කියන එක නා 0 වෙනවා ඔක්කොම charge carriers ටික මේකට ආවට පස්සේ කියන්නේ වැඩියට ආවට පස්සේ. ඒතකොට charge carriers ටික ඔක්කොම මේ LCD එකට ඉන්නකොට ආය charge carriers වෙනින් කොහෙන් හරි එන්න බෑ. එතකොට VCE කියලා කියන එක නා further තව VBB increase වුණොත් එහෙම when VBB increase in IB increasing, IB increasing, IC increasing, IC increasing mean VCE decreasing වෙලා 0 වලට වඩා අඩු වෙන්න බෑ. අඩු වුණොත් එහෙම එහෙම වෙන්නේ නැහැ. එතකොට හැම වෙලාවෙම when we increasing furthermore VBB always VCE 0, always ICE maximum, right? එතකොට saturated region. Saturated වුණාට පස්සේ ආයෙ මොකුත් වෙන්න බෑ. Saturated වෙන්නේ මෙන්න මෙතන. right? එතන ලියන්න when we increase VBB furthermore after VBB increase VBB furthermore after reaching the saturation region, after reaching the saturation region, IC is in maximum value. IC in maximum value, that not changed. IC in maximum value. එක උඩ දාගන්න IC max කියලා කියන්නේ VCC over RC. That's not changed. B IC in maximum value, that's not changed. VCE always 0. VCE always 0. VCE always 0. Okay. Right? Write down the problem. Write down the problem. The current gain of a certain NPN transistor is 100. Consider the following diagram. Write down number 1. The problem number 1. When VBB මෙතන PC C කියන එක දාන්න කරනවා VBB කියන එකනාගේ එතන VCC කියන එක කියලා දාන්න 12 කියලා 12 volt. Right. When VBB equals 0, when VBB equals 0, write down number 1. When VBB equals 0, find out IB, IC, IB, IC, the voltage between RC, voltage between RC, VCE, VC, VC. Okay. Find out. Right. So IB equals 0. Why? This is in cutoff region. මේක තියෙන්නේ cutoff region. Therefore, IB equals to 0. IC equals to 0. මුකුත් නැහැ. ඒක පොඩ් බයිස් වල නැහැ. එතන 0.7 වත් අඩුම ගානේ වань. අපි VBE කියලා කියමුකෝ 0.6 කියලා 6 volt. එහෙනම් ඒක නැහැ. මෙතන VBB 0 වුණත් එහෙනම් VRC equals to what? F0 නේ. VCE equals to what? 12 volts. VC mean this is 0, this is 12. So 12. Right? The VCE mean VC minus VE. VC mean 12. VE කියලා කියන්නේ 0. එහෙනම් VC equals 12. 12 නේ. අනිත් මෙතන relative ගත්තොත් මෙතන earth කරලානේ තියෙන්නේ. එහෙනම් මෙතන ඇවිල්ලා මෙතන තියෙන value 12. Okay. Okay. Write down number 2. Number 2. So this is cutoff region. Number 2. When VBB equals to 2 volt. Find out IB, IC, delta VRC, voltage across RC, VCE, VC, power of transistor. P equals VI, V කියලා කියන්නේ VCE, I කියලා කියන්නේ IC. මේ power එක කියලා කියන්නේ power of transistor. V CE IC. Power out එක power out. transistor කියන power out එක කියලා කියන්නේ output එක VCE IC. VCE into IC. Right. Power out. P out of transistor. Okay, find out that. So how can we find out this IB? IB කියලා කියන්නේ VB equals 2 volts. We have to apply the Kirchhoff, the first law, second law. So we have to apply I will apply Kirchhoff. sigma E equals sigma ER. That means to this direction. So sigma E means BBB equals to the IB RB plus BBE. IB RB means IB 100 into 10 to the power 3. BBE means 0.6. BBB means 2 volts. 2 volts. So 1.4 IB into 10 to the power 5. That means 14 into 10 to the power minus 6. IB equals 14 microamp. Right? Okay. 14 microamps. So IC mean what? We have to use the IC equals beta IB. Right? That means beta means 100 into IB means 14 into 10 to the power minus 6. That means 14 into 10 to the power minus 4. That means 1.4 milliamps. So VRC means delta VRC means the potential across this one ICRC. ICRC. That means IC means 1.4 10 to the power minus 3. RC again 2 kilo ohm. 2 into 10 to the power 3. That means 2.8 volts. 2.8 volts. VCE means we have to apply Kirchhoff's law. Apply KVL across second loop. Second loop. V sigma E equals sigma ER. Sigma E means 12 equals sigma ER. ICRC plus VCE. ICRC 1.4 into 10 to the power 3. RC means 2 kilo ohm. That means we no need to find out that one. And find so 2.8 12 2.8 plus VCE. VCE equals 9.2. 9.2, right? Therefore 9.2 ohm. VC means V equals 0. Therefore this is also 9.2 ohms. Therefore we have to find out what is the power of the transistor. So after finding all this, so power of the transistor power equals to VCE IC. VCE means 9.2, IC means 1.4 into 10 to the power minus 6. So what is the value? 12.8. 12. 9.2 into 12.8. 12.88 milliwatt. 12.88 milliwatt. So this is the right. Correct. So number 3. When VBB equals 3 volt, find out power. Power of the 3 volt. Find out power of resistor. Power transistor. But when find out the power of transistor, you need to find out all the things. All the හැම එකම හොයාගන්න වෙනවා. හැම එකම හොයාගන්න වෙනවා. ඔය කොහොමද බලන්න. So what is the IB? IB කියන එක නා අපි කිව්වොත් 24 microamperes. Yes, IB equals to 24 microamperes. Therefore IC equals to 2.4 milliampere. So make one VCE. What is the VCE? 7.2. 7.2. So the power is P transistor VCE into IC. That means 7.2 into 2.4 into 10 to the power minus 3. 7.28. No. Right. So then find out number 3. Number 4. To get VC as 2 volt, to get VC as 2 volt, to get VC as 2 volt, find the VBB. Find the VBB. Number 5. Number 5. To get saturation region, find out VBB. To get saturated, find out VBB. What means saturated? What is the case when saturated? VCE equals to 0. VCE කියන එක න 0 උනත් තමයි saturated වෙන්නේ. Right. බලන්න VCE කිව්වොත් හරි VCE equals to 2 volt වෙන්න VBB මොකද්ද? VCE equals to 0 වෙන්න VBB මොකද්ද? Right. අර්ථ ගන්න. So what is VCE and VCE equals, what is the VBB? VBB means we have to find out when VCE equals to this one, we have to find out first of all what is the IC. So considering second loop. අපි මේ loop එක consider කරලා ගන්නවා VCC equals ICRC plus VCE. ICRC කියලා කියන්නේ IC into RC means 2 into 10 to the power 3. So VCE means VCE means 2 volt. So VCC means 12 volt. That means 10 volt. IC into 2 into 10 to the power 3. So IC equals 5 milliamperes. Right? Therefore, we have to find out then IB. IB, how can I find out? IC equals P to IB. IB equals IC over B. IC means 5 into 10 to the power minus 3 into 100. That means 10 to the power minus 5. 50 into 10 to the power minus 16. That means 50 microamperes. right? 50 microamperes. Okay. Then considering first law. Considering first law. So sigma E equals sigma ER. Sigma E means PVB. Sigma IR means IBRB plus VBE. IBRB can 100 kilo ohms into IB. 100 into 10 to the power minus 10 to the power 3. Uh, IB means 50. 50 into 10 to the power minus 6 plus BB. That means 0.7. 0.6. That means 1, 2, 3, and this 3 cancel out. 5 plus 6, 5.6. So this is BBB equal 5.6. Are they? Yes. Therefore, BBB equals 5.64. Right? Then find out the BC is 0. What is the BBB? And also find out the okay, outcome BBB available හම්බ IC හම්බ වෙනවා IB හම්බ වෙනවා VBB අන්තිමට තමයි හම්බ වෙන්නේ. Right. So what is the and also find out the sixth one. Add කරන්න when VBB equals to 8 volt, find VC, IC, IB. You find out that one also. මේ ප්‍රොබ්ලම් එකෙන් ඔක්කොම කවර් වෙනවා. right. ඒලා මේ බේසික් එක.
So I think this is the zero to
Okay. For this one, the VCE equals to 0. That means this comes to the saturation. Saturation. VCE equals 0. For that case, we have to apply the considering second loop. Make it consider a second loop. Right? So apply KVL. Sigma E equals sigma E. So the VCC equals to 12 equals to ICRC plus BCP equals to 0. That means IC into RC 2 into 10 to the power 3. So 12, which is 6. IC equals to 6 milliampere. So this is the maximum current. IC maximum. So the IC cannot be increased furthermore, right? In this case, all the charge carriers are coming to the action, right? So the IC cannot be increased furthermore, right? Therefore, when the VC equals 0, so then I have to take the IB. IB equals to IC over beta. That means IC means 6 into 10 to the power minus 3. That means 100. Therefore, 60 microampere. 16 into 10 to the power minus 6. 60 microampere. Right? So, then we have to apply, find out the BBB considering first loop. पहले loop पे consider करते हैं हम apply KVL sigma E equals sigma ER sigma E क्या लगे आने first loop पे क्या दी BBB equals IBRB plus VBE. So BBB IBRB 16 10 to the power minus 3 6 into RB mean 100 into 10 to the power minus 3 plus 3 plus 0.6. That means 1 2 3 this 3 cancel out 6.6. So therefore BBB equals to 6.64. Okay. Right. So the sixth one. Okay. I have it. Right. After the sixth one. So these are easy problem. So most of the cases they are asking this type of questions, and also the application of this transistors we need to know. Application of transistors. देखिए बस से भी करना है transistors. Okay. So when considering the VBB equals to 8P important. So we have to consider same case. We have to consider the this one. So VCE equals to what? VBB equals to that mean. So after the saturation, VCE equals to 0. If you calculated that value, you got minus value. That is not the yes. The real thing is it is saturated. VCE equals remains 0. Make VCE again. After saturation, it cannot be negative. IC equals to what? IC equals to not a 7 point like what? It is 6 milliamp. 6 milliamp. IA. Saturated product was saturated. Right? That means the IB equals to 60 micron. After saturation, it is same, right? After saturation, they are same. Not a 7.2 and 72, right? They are same. Okay. So this is the why is it? We need to take an idea about what is the saturation region. So in this problem, this is in active region. So this is cutoff. This is cutoff. This is active. This is active. This is saturated. This is this is active. This is also active. This is saturated. This is saturated. Right? After VBB getting the 6.6 volt, it gets saturated. That means after that VC equals 0, everything is saturated. Right? Okay. Then write down Two methods of biasing. Two methods of biasing. Two methods of biasing. Number one, base resistor biasing. Two methods of biasing. Base resistor biasing. So, in this case, we need to use the resistor to the that means we have to use that is also resistor. So this time is VCC. Right? So this line having RB, RC. So this is base, this is collector, this is emitter. So we are using මෙතන 0 කරලා ඔන්න bias කරන මෙතන මේ bias එකට base එකට resistor එකක් use කරලා bias කරනවා. එතකොට මෙතනදී so there is a current passing through IC. So this is IB, then IE or right. These are the first method. Okay. First of all, draw this one. Write down the simplest method of biasing is the base resistor method. Which base simpler method of the biasing is the base resistor method. In this method, the supply voltage terminal is connected to the supply voltage terminal is connected to the base through a resistor known as the base resistor. Known as the base resistor. Okay, in this case we no need to move things. So I will apply V equals IR to this branch, right? So there is a voltage VCE, VBE. Apply voltage to this one. So VCC equals first one. VCC equals ICRC. One may path again. ICRC may path again plus VCE. So applying V equals IR. VCC equals VCC equals IBRB plus VB. So this will right. Okay. Write down this one. In amplifying circuit, amplifying circuit has to be designed using a silicon diode, using a silicon NPN transistor, using a silicon NPN transistor of beta equals 100 and a DC supply of voltage 6 volt. 6 volt. Use the base resistors to biasing. And draw the relevant circuit. If the IC should be 5 milliampere, calculate the value of RB. And RC. Right. Find out that. Equal to 1. අරගෙන තමයි හරි මම ඩයග්‍රෑම් එක මොනවද දින්නා the base collector emitter Monkey IC equals 5 milliamperes with yes. So this is the method. So this is maintained in a 0. 0.6. Take the value as 0.6. So this one can be connected to directly the terminal of the earth. Okay. Find out the value. B equals to 100. Huh? So you need to find out the RC value and B value. So VCE value taking as the VCC over 2. एक අපි මේ මේක අපි signal amplification වලදී කතා කරනවා VCE කියලා කියන්නේ ඇයි මෙහෙම තියාගන්නේ කියලා අපිට මේ signal එකක් amplify කරනකොට ඒ signal එක මේ හරියටම signal එකක් විදියට එන්න නම් අපිට VCE කියන එක නම් VCC over 2 වලින් තියාගන්න ඕනේ හරියටම සිග්නල් එක එන්න නැත්නම් එතන පොඩි ප්‍රොබ්ලම් එකක් එනවා. ඒ සිග්නල් එක වෙනස් වෙනවා. දැන් මේ so මේක අපි load line එකක් කියලා ගන්නවා load line එකේ හරියට මැද point එකක් තියෙන ඒ point එක ගන්න හිතුව තමයි මේක මේ VCC out වෙන්නේ අපි ඒක ඉස්සරහ ඩිස්කස් කරනවා so when I apply the V equals IR to this branch in a branch के हम V equals IR ना that means VCC equals to ICRC plus VCE ICRC means 5 milliampere, 5 into 10 to the power minus 10. RC mean, RC we want 5, VCE mean 3 volts. This is 6 volts. That means 6 minus 3, 5 into 10 to the power minus 3 RC. RC equals to the 300 over 3000 over 5. 3000 over 5 means 600 ohms. Right? That means 0.6 kilo ohm. Then we have to apply against V equals IR. V equals IR. So when we apply V equals IR to another branch, so I can find it. So VCC over IBRB and we know what the value are of IB. We have to take the value. What is the IB value? So IB mean IC over V today. IC mean 5 milliampere. Beta mean 100. 15 to 10 to the power minus 6. 50 milliampere microamperes. Right? 50 microamperes. So we need to find out the this is known as 50 microampere. This is in the active range, right? So we have to get the V equals IR. So VCC equals IBRB plus VCP. So IB is 50 microampere means 10 to the power minus 6 to RB plus VB means 6.6, VCC means 6. That means 5.4, 15 to 10 to the power minus 6 into RB. So RB equals to 5.4 into 10 to the power 6 over 50. So it is 5. 108,000 kilo. Right. So මෙන්න මේක මතක තියාගන්න නෝට් එකක් දැම්මත් ගන්නත් නැහැ DCC over 2 වලින් තමයි VCC තියාගන්න ඕනේ load ඒ කියන්නේ අපි දෙන සිග්නල් එක දැන් මේ අපි තාම සිග්නල් එකක් ඉන්පුට් කරන එක ගැන කතා කරන්නේ නැහැ අපි සිග්නල් එකක් ඉන්පුට් කරන එක කතා කරන්නේ නැහැ සිග්නල් එකක් ඉන්පුට් කරන්නේ කොහෙන්ද මෙන්න මේ පැත්තෙන් ඉන්පුට් කරන්නේ සිග්නල් එකක් ඉන්පුට් කරද්දී වෝල්ටේජ් සිග්නල් එකක් තමයි ඉන්පුට් කරන්නේ output එක ගන්න අපි ඊට පස්සේ කතා කරන්න තියෙන එක ගැන තමයි right අපි මෙතනින් output එක ගන්න මෙතනින් output මෙන්න මේ ඉතින් output එක ගන්නකොට අපි ලස්සනට ඒ සිග්නල් එක කට් වෙන්නේ නැතුව right as it is ගන්න කියන්නේ amplify වෙලා සිග්නල් එක ඒ විදිහට වෙන්න නම් VCC output වල මේන්ටේන් කරන්න ඒක පොඩි මේ හරියට තියරි එක විදිහට ඒ වෙලාවට කියන්නේ right ඊට පස්සේ යන්න second one voltage dividing voltage second one voltage dividing method so potential divider biasing කියලා potential divide bias potential divider biasing we are using the potential dividing method right मैं මෙහෙම potential dividing method එකක් use කරනවා මෙතන add කරනවා. එතකොට අපිට මේකට ආයේ මේ VBB කියලා වෙනම supply එකක් දෙන්න ඕනේ. නේ? මේකට ආයේ වෙනම supply එකක් දෙන්න ඕනේ VBB. base එක කෙලින්ම bias කරලා දෙන්නේ. right? ඒක bias කරන්න ලේසි දෙයක්. එකම voltage supply එකකට connect කරන එක ලේසි. ඇයි අපි when we are using this display in the circuit, there is only one voltage supply. We can use the earth component and we can divide the voltage and we can bias the PE junction, right? Transistor එක circuit එකට connect කරනකොට මෙහෙමයි කරන්නේ. Right. So how can I find the first of all draw the graph, draw the diagram. VCE, VBE, look that. Then we have to note down what is the potential difference between these terminals. So this is 0. I will take it as VBE, right? So this is mean, this is VB. So I will take as V2. This is V1. So I need to divide the VCC potential to R1 to R2. Potential dividing method කරන්නේ. Considering potential dividing, I have to divide them V1 to V2 ratio, R1 to R2 ratio. So I divide in VCC. So how can I divide? R1 plus R2 into VCC. R1 plus R2 into VCC. මේක මතකද? මෙහෙම තිබ්බ potential එක අපි divide කරනවා මේකට ratio එකට. Right? We have to take the summation of that. කියන්නේ මෙහෙම තිබ්බොත් එම් 10 volt වගේ තිබ්බොත් V1 ට V2 ගේ ratio එක 2 to 3 තියෙනවා. මොනවද කරන්නේ? 10 කියන එක අරගෙන 5 බෙදලා 2 වැඩි කරනවා. 10 කියලා අරගෙන 5 බෙදලා 3 වැඩි කරනවා. ඒ වගේ දෙයක් තියෙනවා. Right? Easy. Right? So we can find out what is the P2. P2 කියලා කියන්නේ මොකක්ද කියලා ගන්න පුළුවන්. P2 කියලා කියන්නේ so V2 equals to R1 plus R2 into VCC. Right? That means the potential of this one. That means the potential of V2 equals to potential of the base VB. Potential of the base. අපිට basic potential එක කියලා කියන්න පුළුවන් y. This is 0. This is 0. This is V2. Right? So potential of the base equals to that. So I will apply V equals I. දැන් මම v equals ir දාන්න. කොහෙටද දාන්නේ? From this place to this place. From this place to this place. How can I obtain? So v equals ir. v එනවා v කියලා කියන කොච්චරද? v2. v2 or vb equals ib into මොකුත් නැහැ, right? එතකොට මෙතන තියෙනවා vbe plus ie re. v2 කියලා කියන්නේ මොකක්ද? vb vb vb, right? ඒකට තමයි vb කියලා කියන්නේ. Right? That means r2 මෙන්න මෙයාගෙන් ගන්න පුළුවන් r2 r1 plus r2 into vcc equals vbe plus ie re. දැන් අපේ ප්‍රොබ්ලම්ස් වල මොන විදිහට දාලා සිම්ප්ලිෆයි කරන්න. right අපි ඕකේ ආයෙ තව එකක් හොයාගන්න පුළුවන්. මේ තව මොන මෙතන දාන්න පුළුවන්. තව මේ ගාන හදනකොට අපි එකක් බලමු. apply v equals ir මෙතනලා මෙතනට දාන්න පුළුවන්. vcc equals ic rc vce ie ये वाली इक्वेशंस टिका करेंगे ना अपने मुझे सिंपल करना मम्मी ने मेथड ला मेथड है vcc equals icrc plus vce plus iera, right? ये सब बताना right? ये करना है ना बच्चा अभी का प्रॉब्लम है. Okay. Then write down problem. Take a problem याद करो. मैं write down an amplifier circuit with a potential divider biasing is shown as follows. Biasing as follows. Assuming that the silicon resistor has been used. Taking the VCE equals VCC over 2 calculate following. VB taken as 0.7 volt, right? 0.7 volt of the this terminal IC equals 2 milliampere. So find out number 1 VE, number 2 VB, number 3 VC, number 4 RC, number 5 RB, number 6 VBC, number 7 uh, that's enough. That's it. Take IE plus IC approximate equals to IC plus IB approximate equals to the IB, right? When we are calculating this, IB is not nearby. The I minus IB here almost equals to the I. මෙතන එනවා 2 amps මෙතන microamps range එකක් යනවා වැඩක් නැහැ. මෙතන මේ එනවා 3 milliamps මෙතන microamps පහක් වගේ ආවක් වැඩක් නැහැ. එතන මෙතනත් අපිට ගන්න පුළුවන් I equals I C plus IB. It is approximately equals to the IC, right? Right. ඒ කියන්නේ IB කියන එකෙන් වෙන ඉෆෙක්ට් එක ගොඩක් අඩුයි. ඒක කන්සිඩර් කරන්න නැතුව හදන්න දෙන්න. So we have to find out what is the VE. Find out VE. We have to take this voltage. So මෙතන යනකොට voltage එක values දෙනවා මෙතන 0 මෙතන E. Therefore VE equals to IE RE. So IE can be taken as the 2 milliampere. Why? This can be taken as the IC, right? Why? This is the E. So that means 2 into 10 to the power minus 3 into RE. RE means 1.2. 2.4 VE equals, okay, so that means 2.4. VB means VBE we know VBE equals V minus VE. So VB equals 0.7. So VB minus VE 2.4. VB means 2.4 plus 0.7. Right? That means 3.1. VC means VCE equals to 6 volt. VC minus VE equals 6 volt. VC equals 6 plus VE. That means 6 plus VE in the 2.4. 8.4. So that's yeah, right? So this is the terminal of VC. VC. So this is the VC. This is the VE. So this is VCC. So VC equals to 8.4. So how can we find the RC? To find the RC, number 4, apply V equals IR. VCC equals 12 volt. 12 volt equals to what? ICRC plus VC. එතන යාට යන්න ඕනේ නැහැ නේ මේ VC කියන එක නම් පොටෙන්ෂල් එක ගන්නවා. එහෙනම් RC කියන එක නහර. Okay? What is the IC? What is the RC? So the 12 plus ICRC, IC කියලා කියන්නේ 2 into 10 to the power minus 3 RC plus VC කියලා කියන්නේ 8.4. That means this 12 minus 8.4 2 into 10 to the power minus 3 RC. Right, 3.6 over 2 10 to the power minus 3 RC means 1.8 kilo. RB කියන එක නම හොයාගන්න අපිට තව කේස් එකක් දාගන්න. දැන් මෙතන BB අපි හොයාගත්තද 3.1 කියලා හොයාගත්තා නේද? This is 3.1. This is 12 volts. Right? We need to find what is the I. I mean this is 0 volt. So you need to find out what is the I passing through this one. I. Then you have to find the I. Right? Then you can find the RB. Right? That's the way of taking the RB. So what is the value of the RB? First of all we have to find out what is the I. So I කියන එක හොයාගෙන තියන්න හරියට. I කියන එක නම හොයාගත්තා නම් හරි. So how can we find the I? So find the I. We have to apply, considering this one, we have to apply V equals IR. Let me tell you. V equals IR. So potential, the difference means 3.1. I into R mean 18 kilo ohm 10 to the power 3. So I equals 3.1 over 118 10 to the power minus 3. So 0.17 milliamperes. 0.17 milliamperes. Regarding to this, IP is not considerable because this is microampere range, right? So then we have to apply V equals IR to this. So what is the potential? 3.1 and 12 volts. So the delta equals to 12 minus 3.1. That means 8.9. 8.9. So I'll apply. Considering that, apply V equals I. 8.9 equals I mean 0.17 10 to the power minus 3 into RB. So the RB means 89 over 0.17. So RB equals to what? $523.5 kilo. So R means 520 3.5 kilo. So what is the BC? BBC. BBC mean BE minus BC. BB mean 3.1 minus BC mean 8.5.